Assalamualaikum and very good evening to all of you. Welcome back to this video, which is for tutorial 2.7. We will discuss about the ultimate moment resistance for flange beam section at the midspan, where we will consider the singly reinforced. Okay, you can refer to the module page 59 actually, okay, page 59. And the question is determine the ultimate moment of resistance for the beam with flange cross sections. Okay, this is the keyword, important keyword, and located near the midspan. Okay, the data in this figure is given. Okay, where the total is 4H25. So you just use this one, and actually we have another one here. Okay, we shall have another one still bar. Okay, so let's start. Okay, first of all, we have to calculate the D. I believe after a few exercises, you must be familiar on how to determine the value of D. So based on my calculations, you can insert the corresponding value letter, and the final answer shall be 4.5 mm. Okay, and then you have to draw or sketch the stress block diagram. For this case, you can refer to page number 25 in the module, where we consider the existence of flange. So as this one, okay, this is the sections. Okay, we have flange at both left and right side of the beam, and this is the stress block. Okay, so we have to consider the FST, of course. This is forces, okay, internal forces in the steel due to tensions, and then this is the we recall back our memory from the rectangular beam. So FCC1 is here. Okay, the compressions inside the web, and FCC2 is the compressions inside the flange. Okay, where the HF is equal to the thickness of the slab. Okay, next. So the area of number one. Okay, this is A1. Area of number one. Area of number one is equal to here BW multiplied by this one. Okay, let's see here 0.8x. Okay, just like the situation for the singly reinforced before. So A1 is equal to BW multiplied by 0.8x. Okay, and then we have A2. A2 is from the flange. Okay, we have the A2 area number 2 from for both left and right sides. So let's say this is B1 and this is the B2. So equal to B1 plus B2 times the thickness of the slab, which is the HF. Okay, so the B1 and B2 is equal to the flange width minus the BW. Okay, we have to minus BW and multiply by the HF. Okay, so this is our A1 and A2. So we have the FCC1, the compressive force in the concrete. Okay, in the web. Okay, so the stress in concrete, it shall be stress should be 0.567 FCK. So multiply by the area, which is A1. Okay, A1. So BW multiply by 0.8x. So you insert the value of FCK and BW in these equations. So you shall have here, what is the answer? Okay, 2835x. Okay, the unit is in Newton. Okay. Next, we calculate the FCC2, which is the compressive, okay, the compressions inside the flange. So compression, the stress in concrete is 0.567 FCK multiplied by B effective minus BW times HF. Okay, you insert the value of every parameter here, and FCC2 equal to okay 44296. Okay, let's 9. Okay, okay, make it. Okay, so you can write down the value here later. Okay, and then for the internal force in the steel due to tensions is 0.87 FYK times the AS provided. So you just insert the value in this equation. So what is the value? 854,340 Newton. Okay. Next, okay, for equilibrium, okay, here we have FCC2 and FCC1 undergo the compressions. Okay, this is for compression, and FST for tension, so it must be equal. So just enter the value of FST, FCC1, and FCC2 we calculated before. So what is the value of X? Okay, 145.1 mm. Okay, you can try later. And then ultimate resistance, okay, observe carefully. So moment about the center of the tension reinforcement. So FCC1 times Z1 plus FCC2 times the distance, which is Z2. So just follow these equations. So I believe, okay, please be careful. Okay, let's do it together. Okay, better we do it together. 2835x. Okay, and then multiply by B minus 0.4x. And then plus 442,969. Okay, multiply by D minus HF over 2. Okay, and then you just insert the value of D, X, and HF. I kindly advise you to settle one by one. Okay, rather than doing at one time using your calculator, because we have minus and we have plus here. So sometimes the student doing mistake at this stage. So you better settle this one first, and then you can settle another one. Okay, so the final answer shall be 328 kilonewton meter. Okay, so be careful. You settle FCC1 times Z1, and then you settle FCC2 times Z2, and then you do the final solutions before you got the final answer. Okay. So congratulations, class. You just finished the tutorial 2.7, and then you can refer to the module for the exercise in page 62 to 63. Okay, thank you very much for watching this video. I hope I can see you again in our next video. Bye-bye.